Welcome back, grade 12. Let us now discuss the solutions relating to 9.1. So in 9.1, this is what we are told. Let's go back again. Let's apply our pre-question analysis. I love that one because it always assists us and it helps us to know which direction we are going to take. Let us look at this one. In the diagram, O is the center of the circle. Okay, we are told that O is the center of the circle. OD bisect chord AB. Okay, so OD is bisecting AB, meaning AD and DB are equal. They are even showing us from the diagram. Prove the theorem. So we are proving a theorem that states that the line from the center of the circle that bisects the chord is perpendicular to the chord. In simple terms, we are proving that OD is perpendicular to AB. So that's what we are required to prove. Now, how do we prove this one? Remember, any proof must always go with a construction. How do we prove this theorem? Number one, remember, we are going to prove this theorem using congruency. And to do that, or to prove using congruency, we need to have the triangles, or we need to work with the triangles. Now, when we're working with the triangles here, what are we saying? Now, we need to create the two triangles here. How do we create those two triangles? We are going to create them using construction. Let us construct OA. And remember, you must show this construction on our answer sheet. You must show that construction, and remember the constructions are done with dotted lines. So make sure that you do the construction, and that construction it is done with the dotted lines. Let us proceed. Then we are saying draw OB again. So we are going to join OB so that we are having triangle AOD and triangle BOD. So those are the two triangles that I am having. Let us see. So we are saying in triangle ADO, which is the first triangle now from construction, and in triangle DOBDO. So those are the two triangles I'm going to work with to prove congruency. We can say that OA is equal to OB. So these two lines are equal. We are saying the reason here is radii. Those are the two radiuses. We are saying those are two lines that are drawn from the center. So there are two radiuses and they are radii. Number two, but we notice that OD, it is a side for the triangle on my left, and it's also a side for the triangle on my right. So OD is equal to OD because OD it exists in both sides, both triangles. What else? And we are told that AD is equal to DB. How do we know that? We were told that OD bisect AB. So because OD bisect AB, to bisect, remember, is to cut into two equal halves. Then we know that those two are equal. Then we can now say triangle ADO is congruent to triangle BDO. And the reason here it is a side. This was another side. This was another side. So that is side, side, side. Then we can now conclude again that ABD it is a straight line. If ABD it is a straight line, meaning now D1, or we can call this one D1 again, and D2, we can call that these two angles are equal. It is from congruency. Then we can conclude that OD is perpendicular to AB, and these are angles on a straight line. So that's what we are dealing with. We are saying if this is a straight line, and this line is bisecting the two sides there, and D1 equals to D2, then D1 and D2 must be 90, and so they can give us 180, which is the angles on a straight line. Now, grade 12, let us move on to question 9.2. So for this question 9.2, grade 12, you are given 12 minutes to complete this activity. And your 12 minutes countdown starts now. Welcome back, grade 12. Let us now discuss the solutions to this activity. Now, what are we saying? We are told that in the diagram, E, B, F, S are the points on the circle. Okay, we have those points are on the circle, centered at O. GB is the tangent to the circle at B. Okay, so we are told that this is a tangent. Very important. Remember, when we're told that it is a tangent, we remember all the tangent theorem that we can apply. The tan chord, tangent being perpendicular to the radius or being perpendicular to a diameter. So we are going to work with those. It is drawn such that T is the midpoint of EF. Okay, that means T divides EF into two equal halves. GO and BO are drawn. BS is drawn through T and PS is parallel to GF. Let us apply this information by doing what? By applying our doctor there, Dr. Cape Town. Let us apply our doctor Cape Town. Let us see. Do we have any diameter? No, we do not have a diameter. We are told that O is the center, but there is no line that passes through that center. So we don't have a diameter. The statement does not point any diameter. So we're not going to work with the diameter for this question. Do we have any radiuses? Do we have any line drawn from the center to the circumference of the circle? Remember, radiuses, I can tell you that these are radiuses, or we must be able to see the radiuses from what? We must be able to see the radiuses from a line drawn from the center. Let us look at that. Do we have any? Yes, we have a radius. We have our radius BO right there. What else do we have? Do we have any cyclic quads? The statement never pointed anything about a cyclic quad. But let us go look at the diagram. Are we having any 4 points on a circumference that are connected together? We have more than 4 points on a circumference, but none of those, there are no 4 consecutive points that are connected together. So we don't have a cyclic quad. So we are not going to work with any cyclic quadrilateral properties here. Do you have any parallel lines? Yes, we do have parallel lines. There we go. We were told even in our statement that PS, it is parallel to what? To GF. So PF is parallel to GF. And when you think of those parallel lines, we're going to look at our fun here. Always say when you see parallel lines, we are supposed to have fun. When you're having fun, we're going to look at for the first F, our F there is for corresponding, our U is for contrarian, our N, you can see it as Z nicely there, it is for alternate, and so that is the fun that we're going to have. Let us think. Do we have any corresponding? Can you point out any F shape? Yes, I can. Can see that this one and that angle T and S are going to be equal. Any co-interior, we can also look at the co-interior right here. We have them. This one and that angle will also be co-interior. Any alternate angles? No, I'm not forming any Z shape or N shape in this case. So what are we saying? We are going to have our corresponding, we are having the co-interior. So those are the two properties that we must keep in our head. We are going to apply them if needs be. Do we have any tangent? Yes. We were told that FE is produced to meet the tangent at G. It's produced, where is FE? My FE is produced to meet the tangent at G. Then which one is our tangent in this case? Our tangent is going to be GB. So that is our tangent. And we have, remember we had the radius. So tangent perpendicular to the radius, we are having that again. So those are the principles that we are having on our diagram. So that is part of our pre-analysis. We can see that ET is also equals to TF. And when those two are equal, we can see that this angle is also going to be 90, and that angle that side is going to be 90. So it's very interesting. That is how we are going to apply our pre-analysis. Let us look at 9.2.1. We are required to prove that O, T, B, G, it is a cyclic quad. So we want to prove that all of those points, they are lying on the circumference of the circle. Now, to prove a cyclic quad, remember, we can prove that opposite sides are supplementary of a cyclic quad. We can prove an exterior angle of a cyclic quad. We can prove our bow tie. If you remember, what is a bow tie there? We can prove the angle in the subtended by the same chord or subtended by the same arc. Can you prove this one? No, I cannot see this shape. This cannot work for me. Do I have any exterior line out of that, out of those 4 points that I have circled with a red there? No, I don't have any exterior line. So we are only left with opposite sides being adding up to the opposite sides adding up to how much? They're adding up to 180. But I remember that this is 90 from my pre-analysis of the question. So if that is 90 again, what else do I remember, or what else would I know? I also would know that this is also 90 right there. And why are those two 90? Because this one, it was a tangent perpendicular to the radius, as GB is the tangent, and the angle on the T there, it is 90 because BT it bisects that chord. But let's now look at the formal proof. We are now saying OTG, it is actually 90. Why? So these two are 90 and that one is also 90. So I've drawn only 190. Why? This is because of the line from the center to the midpoint of the chord. So there's a line we're having from the center to the midpoint of our chord. So that is the line that we are looking at to give us the 90 degrees right there. Again, we are told that OBG, it is actually 90 degrees also. OBG is also 90. And what are we going to say for the reason there? It is the tangent perpendicular to the radius. But again, if we can see, this actually comes back to say this is now valid for us. Think about it, because we're going to have GO, and that GO is going to subtend the two angles. So to show that, let us do this. If you can check the GO, okay, can see even if I didn't see the shape, but now the shape is visible easily there. So we can see those two angles there that are given by that line. So GO, so we can say OTG is equals to OBG. These both of them are equals to 90. Because we've proven that both of them are equals to 90. However, we can conclude that OTBG, it is a cyclic quad. Why? Because the angles substance, line substance equal angles, or the converse of the angles in the same segment. As you can see that GO subtended those two angles there. So these two are equal. Then if you connect it to a reason, it is the one of saying the line substance equal angles. Then we can prove that this is our cyclic quad. Let us look at 9.2.2. 9.2.2, we are required to prove that GOB, it is equal to S. And remember, when we are moving on from that question of saying we have proven that this is a cyclic quad, we are going to apply those principles of it being a cyclic quad. So we mustn't forget that we are still going to work with this cyclic quad. We are going to still work with that 90. We are going to still work with that 90 right there. So we mustn't forget those two that we're going to apply. Now, let us check this one. But we know that angle S, remember, we're going to still work with those corresponding angles we have identified from pre-analysis. S is equals to BTG. So those are the corresponding angles. We have identified this from our pre-analysis of the question. Again, we know that BTG, it's BTG is equals to GOB. Why? Because this is going to give us this one are the angles in the same segment. Remember, this OTG B, it is our cyclic quad as we have proven in the previous question. So we can see that we have angles in the same segment. Right. So we have that angle and that angle being equal. Then let's proceed. Now, therefore, we can say GOB is equals to S because those two angles are equal. So it is equals to S. Then we have proven that, let's proceed. Then we have proven that GOB is equals to now SY. Both of them are equals to BTG. So that is how we prove that that is a cyclic quad. Now, grade 12, we have another activity here. So this is question 10 of our work. So for this question, you are given 15 minutes to complete this activity. Your 15 minutes starts now. Welcome back, grade 12. Let us now deal with question 10. In the diagram, PQRS is a cyclic quadrilateral where KP is the tangent to the circle at P and PS, PQ and chord PK, I'm here. C and D are the points on the chord PQ and PS respectively, and CD produced to meet RS produced at A, and CA is parallel to QS, and RC is drawn where P1 is equal to R1. Now we are going to apply our pre-analysis of the question. And we can see from the previous question that the pre-analysis have helped us to be able to work with the questions that we are having. Now, without looking at our questions, let us look at our pre-analysis. When you look at our pre-analysis, remember, we are working with Dr. CPT. But before we do that, let us see what the statement gives us first, then we can apply our doctor there. PQRS is a cyclic quad. PQRS is a cyclic quad. We're told that even without the question pointing it out for us, we will know that is a cyclic quad because those are the 4 points on a circumference that are connected together. So we can think of those concepts or those properties of a cyclic quad. Let's proceed. KP, it is a tangent. Okay. If KP is a tangent, I'm already thinking of the tan chord already. Right. Tan chord, remember, we must be able to draw a triangle where it is meeting, where the chord is meeting the second. Let us draw that triangle. Let's see if we can have any triangle that is going to work with us on the tan chord. So I'm going to use the different color. And remember, it's very much important when you apply Euclidean geometry, be able to work with multiple colors. It's going to assist us a lot. We can see that this and that are going to be equal. That is our tan chord theorem right there. So we can see that the two are equal. I'm just going to mark with A and X so that we don't forget that those are equal according to the tan chord. Let's proceed. Okay, we have the chord. They are produced to meet at at A, and we're told that CA is parallel. So we can see we have parallel lines. It's parallel to QS. Let's see. Diameter, there was no diameter given. There was no radius. There is no center, but we have the cyclic quad. We dealt with that. Parallel lines. Let us work on the parallel lines with our doctor. Parallel lines, remember, this is where we are going to have fun. When we are dealing with those parallel lines, let's see. Do I see any F shape? Okay, let's see. I do see it. There is my F shape. So those, I expect them to be equal. Let's proceed. Do we have any cointeria? We do have cointeria. So those are the cointeria. Do we have any alternate? Our Z or our N? Let's look out for our Z or N. If I can see, I'm having our Z between these two. You can see that S2 and D1 are equal. So as we are identifying these angles, it's very much important that you write them down on your rough work. You can write down S2 is equal to D1 alternate angles. We can write that K1 or P1 is equal to Q1, which is our tan chord. We can write that down, and we can see if those two are equal. Where this is also equal to P2, then those Q1 and Q2 are also equal in that case. We can also work with those opposite angles of a cyclic quad. We can work with the corresponding angles here, where I had an F shape right there. So it's very much important that you are able to write all of this down. So when you're doing the pre-question analysis, remember to write down. Let us look at number 1. Prove with reasons that S1 is equal to T2. We have already established that P1 is equal to Q1. And we have mentioned that to say these are our 10 chords. If you remember from our pre-analysis, because I was able to draw the triangle from that. And what do we see again? We can see that S1 is to go to S1. Our S1 is equals to Q1 plus Q2. And how do we see that? We were told that we had a cyclic quad right there. So that is an exterior angle of a cyclic quad. So that line was giving us an exterior angle right there. So that is the one we're also having. It was not part of pre-analysis. Just forgot to include that one. But that is part of our pre-analysis. It was supposed to be there so that we can see it. Then therefore, we can now conclude that S1 is equals to, our S1 is now equals to P1 plus Q1. Why? Because P1 is already Q1. So I can replace that Q1 here with my P1. So that's why I'm having right there. So I can see now that S1 is now equals to P1 plus Q2. That's what I'm having. So that what is the next thing to do right now? The next thing to do is to check and look at T2. Remember, I've dealt with S1 extensively. I'm done with S1 there. Now I'm trying to find a connection between T2 and S1 by saying what? Can I at least try to get also T2 to be equals to P1 plus Q2? That is what I'm trying to do here. Now let's look at T2. Our T2 is equals to what? Our T2 is equals to R2 plus Q2. Let's change the color. This one. So this one is the sum of the two. So it is an exterior angle of a triangle. What am I trying to do here? I'm trying to form a connection between S1 and T2, and I can see that Q2 is already in S1. So if that is going to be my starting point so that I'm able to have a certain direction. So if I can relate T2 to any P1 or Q2 or any other angle that is closer related to S1 as we have established, then I'm going in the right direction. Then if I can introduce that, but we know that P1 and R1, R2 are equal because those two are given. So this is also equals to that. What can we now say? We can actually just say this is also P1. What do we see? T2 is equals to P1 plus Q2, which is what we're having there. Therefore, T1 is equals to P1 plus Q2. Why? Because R2 can be replaced by P2. What do we see the right then? Because we have that, then we can now say where there was R2, I will replace it with P1 because they're equal as it is given. That's what I was saying to say P1, we can write P1 again here because those two are equal. Remember, with angles that are equal, we can use these letters, or we can just say, if these two are equal, I can call it P1 again, you see. So that I can say R1 is now P1 because they are equal. Therefore, TS1 and S1 and T2 are now equal. Why? Because they are both equals to P1 and P2. So to work with this, work with one angle that has more information, then try to relate the other angle to the information or the conclusions we've made about one angle. Then you'll be safe to go. Prove given reasons that AD over AR, so it's AD. Where is my A? Where is my A? AD over AR. Okay, it's what? It's equals to AS all over AC. So that is what we are trying to work with. So that's what we're doing here. We are trying to work with proportionality. How do we say that? Now we're going to look at the two triangles. So in triangle ASD, because that is where all of those angles they're looking for is found. In triangle ASD and triangle ACR. So triangle ACR is going to be our big triangle. It's ACR. CR. So those are the two triangles that I'm going to work with. So what I'm going to see, I want to see the relationship between the two triangles. We can see that A, it exists for both triangles. So A equals to A is common angle. Number two, we've proven that our S1 is also equals to what? It's equals to T2, which is an angle, one that is falling in our, which is equals to T2. But we need to make a connection with T2 right here. But remember the alternate angles we dealt with on our pre-analysis. So this is where we go back to our notes. We made a connection that we have alternate angles. And when we're having that alternate angles, we are now saying T2 is equals to C2. So we can draw the Z shape right there. Then we can now conclude that our T2, just going to make star here. We can conclude that our T2 is equals to that S1. So far I have two angles, then we can conclude that S1 equals to C2 because they are both equals to C. They are all equals to what? To C2 using that alternate angles. T2, I want to say. Then D1, it's now therefore equals to R1. We can say the sum of angles in a triangle, or this is the third side or third angle. Simpler rule is going to be this our third angle. Because we've proven the two angles already, then the third one we can make a conclusion. Then therefore, triangle ASD is congruent to triangle ACR. Then we can now say the corresponding sides are in proportion because those two are congruent to each other. Then we've proven that they are in proportion. Proof given resistance that AC times SD is equal to AR times TC. How do we work with this? This one works with already the proportionality that we have proven. Remember, we've proven that AD over AR is equals to AS over AC, which is the proportionality proven in a previous question. Even if we didn't or we were unable to prove this proportionality, we can make conclusions from that proportionality and draw them on this question. Number two, then what can we do? We can make AS the subject of the formula. Then we can say AS is equals to AC times SD over CR in that case. So that is what we're also going to work with right there. Then what do we do from here? Then we remember that AS over AR is equals to, so AS all over AR is equals to CT all over CR. This is proportionality because we are told that the two sides are parallel right there. So I can prove that proportionality also. Therefore, AR is equals to AR times CT over CR. So that's what we are now having for this question. Then we can cross multiply. When you cross multiply, we have AC times ASD is equals to AR times TC. So that is how we prove proportionality. We make connection between two triangles that are proportional to each other. Right. So that's how we have dealt with this question. Let us go through this one more time. We can see that AD. So we said AD now. AD. Let me use a different pen so that we can go through this again and we can see how this was applied. So AD, our AD over AR, because we're proving this proportionality, it's equals to AS all over AC. So this was proven from proportionality. So that is what we are having in that case. Then we can see that CR now, when we now work with the AS, we can make AS the subject of the formula. By cross multiply, we're going to have AR But of course, multiply here, we're going to have AR, AS times AS is equals to 80 times AC. So that is what we are having in that case. Then that is why we are going to work from here. We can now say divide by AR, divide by AR. Then our AS initially was supposed to be 80 multiplied by AC all over AR in that case. So that is what we are supposed to be having right there. Right, let's move on. So the summary for this activity, this is what we are saying. Do not make any assumptions. Do not assume that a line is tangent or a diameter until we are told that, or unless we are told that it is a diameter. Number two, we are supposed to look for any keywords in the statement, such as the center, parallel lines, tangent, cyclic quad, and bisects. Number three, continuously update the diagram as you read the statement to find angles. So continuously update that diagram. Number four, when proving theorems, if you don't have any construction, you are not going to get any marks. So you must always make construction and you must make those markings on the diagram. You will always be told that you have a cyclic quad. You will not always be told that you have a cyclic quad. But how do we find a cyclic quad? Check for 4 points on the circumference that are joined together. For every statement, there must be a reason. And remember, one of the useful strategies we can use is the Dr. CPT as our pre-question analysis. As you can see, for this activity, we have worked with that pre-question analysis a lot. That brings us to the end of our revision for Euclidean geometry. I hope you able to apply all the strategies we've used in this so that we can work with our examinations. Thank you. Enjoy the rest of your day.